this section we're going to look at equations that are reducible to quadratic form. Now you are used to seeing equations of the form ax squared plus bx plus c is equal to 0 as quadratic in nature because of that x squared. However, look at the relationship of what we have between the exponents. The exponents go from 2 to 1, and then there's no variable at all, so we have c or cx to the 0 if we want to think of it that way. Now what we're going to see in this section is sometimes we're going to have exponents of 4 and 2. Sometimes we may have something like 6/5 and 3/5. But what's going to be happening is that first exponent will cut in half to the second exponent in that descending order of exponents. Now we notice that in this first problem we have 2/3 and 1/3 as our exponents, and this is going to be factorable. We're going to put an m to the 1/3 at the beginning of each parentheses, because if you think about it, when you're multiplying the f part of FOIL, you're going to be adding exponents 1/3 plus 1/3, which is 2/3. Or another way to look at this is to look at the middle term. Notice that there's an m to the 1/3 there, and that tells you what's going to be at the beginning of each parentheses. At which point we're now going to factor this, have a -3 and a +2 inside each parentheses, and we're going to be able to solve these equations by using the zero product rule. So we would have, and most of us don't usually write this, but we're going to write it, m to the 1/3 minus 3 is equal to 0, or m to the 1/3 plus 2 is equal to 0. Most often, however, we just go straight to m to the 1/3 is equal to 3, or m to the 1/3 is equal to -2. Now we know that a 1/3 power represents a cube root, and the way to solve a cube root equation is to cube each side. But if that wasn't a 1/3 or a different fraction, the easiest way to look at this is to raise each side to the reciprocal power. Notice when you multiply reciprocals, they will cancel each other out and we'll just have m to the first. So I like to just call this the process of raising to the reciprocal power. Technically on this one here, it's the whole -2 being raised to the power. This is going to give us m is equal to 27, or m is equal to -8, both of which will work if you substitute it back into the original equation. The one thing you do have to watch out for is if you have an eventh root and this denominator is even, like the 4th root equal to a -2, then you would have a no solution, at least for that side of the equation. On this next problem, we notice that we've got 2/5 and 1/5 as our exponents, so we're going to factor it. It is in this form. Reducible as a quadratic, and we're going to use a 1/5 power at the beginning of each parentheses. Now we need to make a 7 in the middle, so we want a +1 and a +3, specifically so that the 2 times the 3 on the outer gives us a coefficient of 6, and then we have a 1 in the center making a 7. Now what we can say here is 2t to the 1/5 is equal to -1, or better yet, t to the 1/5 is equal to -1/2, or t to the 1/5 is equal to -3. It's okay to have fifth roots equal to negative numbers. Basically what we want to do is raise each side to the 5/1 power, to the 5th power, to undo the 5th root, and that will give us the solutions of t is equal to -1/32 or -243, both of which are checkable in the original problem. Now, even though we don't see fractional exponents here, we can solve this problem by factoring, but first we want to set it equal to 0. Let's rewrite this as y plus 6 root y minus 16 equals 0, and then we're going to factor this with a square root of y at the beginning of each parentheses. Now the two numbers that multiply to -16 and add up to 6 are going to be +8 and -2. So we will have the square root of y is equal to -8, which makes no sense, or square root of y is equal to 2. And squaring each side, we will have y equals 4. Now you may say, why can't I have a square root equal a negative? I know about imaginary numbers. Now, that's a little bit different. That's when you have the square root of a negative. Okay, this is square root of y equals a negative, which is a different pattern altogether. In this next problem, we see an x plus 6 over 4 squared and an x plus 6 over 4 to the first showing up, and this is reducible to quadratic, but we're going to use something called u substitution. We're going to say let u equal x plus 6 over 4, and we're going to substitute out that fraction for u and rewrite this as 16u squared plus 8u plus 1 equals 0. Now we have a quadratic with the variable u, which we can solve easily. We notice that 4u plus 1 times itself is how we're going to factor this, and setting this equal to 0, we find out that u is going to equal negative 1/4. Well, we can't solve an equation for u when the original variable was x. So what we need to do is back substitute, change the u back into an x plus 6 over 4 equals this negative 1/4, and solve the equation that we have here. Now I can either, well actually instead of cross multiplying, let's just multiply through by 4 on each side, and that will eliminate the denominators and give us x plus 6 equals negative 1, and we can see that x is equal to negative 7. In this next problem, we see the fractions cutting in half. We're going to factor this with an m to the 1/4 at the beginning of each parentheses, and then we're going to find the other two numbers to be negative 6 and positive 4, which multiply to negative 24 and add up to negative 2. So we are going to get m to the 1/4 equals 6, or m to the 1/4 equals negative 4. This is the one on the right that we have to cross off because we have a fourth root equals a negative. If we were to raise both sides to the fourth power and get 256 there, we would find out that that value would not check when we substituted it back into the problem. So I'm going to raise each side to the fourth power, which is the reciprocal power, and that is going to give us m is equal to 1296, which is the solution to this problem. Now, just a comment here before we finish this section. Had we used the quadratic formula, let's say we didn't want to solve this by factoring. We are used to going m equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That would not be the case this time. You would have to have m to the 1/4 equals that, because in the original problem we had m to the 1/4 in the center. Notice that's what we used at the beginning of each parentheses, and that would be what we'd use in the quadratic formula. We would then use the quadratic formula to get our solutions, and then raise each of those solutions to the fourth power to get m by itself.